I will explain in this video statement of Gauss law and its proof. Statement of Gauss laws and its proof. The electric flux passing through any closed surface is equal to the total charge enclosed by that surface. Statement. The electric flux passing through any closed surface is equal to the total charge enclosed by that surface is equal to the total charge enclosed by that surface. In mathematical form, psi is equal to electric flux is represented by psi is equal to total charge Q is equal to integral of ds dot ds, capital DS dot ds. This is the mathematical representation. Consider this figure. Let us imagine a distribution of charge shown as a cloud of point charges surrounded by a closed surface of any shape. This is the distribution of charge as a cloud of point charges. This one is the distribution of charge shown as a cloud of point charges. As a cloud of point charges surrounded by a closed surface. This is the closed irregular surface. Closed irregular surface. First one is distribution of charge. Let us imagine a distribution of charge. Distribution of charge shown as a cloud of point charges. These are the dots are the point charges. That is called as cloud of point charges surrounded by this cloud of point charges surrounded by a closed surface of any space. This is the closed irregular surface or closed surface of any shape. If the total charge is Q, this is the total charge is Q coulombs. If the total charge is Q, then Q coulombs of electric flux will pass through the enclosing surface. Next point here is if the total charge is Q, then Q coulombs of electric flux will pass through the enclosing surface. This is the inside this circle indicates distribution of charges. The distribution of charges as a cloud of point charges. Q is the charge. If the total charge is Q, then Q coulombs of electric flux will pass through the enclosing surface. Coming to this, consider a small incremental element of area delta S. Next point here is consider a small consider a small or consider an incremental element of area delta S. This is the area. Incremental area delta S is very nearly a portion of a is very nearly a portion of a plane surface. Nearly a portion of a plane surface. This is the delta S is an incremental element of area. Is very nearly a portion of plane surface. Next, ds is a vector quantity. It has magnitude and direction. The incremental surface element is a vector quantity. This is the delta S, an incremental surface element. Consider an incremental element of area delta S is very nearly a portion of the plane surface. The incremental surface element is a vector quantity. That means it has a magnitude and direction. The direction is like that, delta S. The only unique direction which may be associated with delta S is the direction of the normal to the plane. Direction of the normal to the plane which is tangent to the surface. Direction of normal. Normal means this is the direction of that, the only unique direction of which may be associated with delta S. This is the direction. Is the direction of the normal to the plane. The direction of the normal means perpendicular to the plane, which is tangent to the tangent to the surface. Very, very important point. The incremental surface element is a vector quantity. It has magnitude and direction. The only unique direction which may be associated with the delta S is the direction of the normal to the plane, which is tangent to the surface, tangent to the surface. This is the small incremental element. Surface element is vector quantity. That means the direction of that one is ds. The direction associated with that ds is the, this is also direction of the normal to the plane. This is also a plane, closed surface plane, which is this direction is which is tangent to that this surface. This is the normal. This is the normal. ds is the direction of the normal to the plane which is tangent to the surface, that has two components. That normal to the surface is in two directions, but only consider directed outwards only, not inwards. This is normal has two directions, outward direction and inward direction. The normal going into the closed surface, or the normal going away from the closed surface. That means outward surface, inward surface. Two directions are there. Consider outward direction only because this is the closed surface. Next important point is the normal to the surface is in two directions, but only directed outwards is considered as required. The normal to the normal to the surface, the normal to the surface is in two directions. Two directions, outward and outwards, and going into the surface, and going into the surface. Outward surface and going into the surface. But we consider outward direction only. We consider outwards direction only. This one. Next one is the electric flux density at a point P is ds due to charge Q. This is the ds. ds is the electric flux density at a point P due to charge Q. Next important point is the electric flux density. The electric flux density at point P is ds. At point P is ds due to charge Q. Due to charge Q. Due to charge Q. This ds making an angle theta with the normal direction at point P. The ds making an angle theta with delta s. The ds making an angle theta with delta s. Delta s is the direction of delta s, which is normal to that plane surface, which is normal to that plane surface. ds making an angle with the delta s. ds making an angle making an angle theta with ds with delta s. Makes an angle theta with the normal direction at point P. Normal direction at point makes this delta x, delta ds. This ds is due to electric flux density at a point P due to charge Q. This ds making an angle theta with the delta s. This delta s, which is normal to that plane surface. The delta S is the normal to the plane surface. That means makes an angle, ds makes an angle theta with the normal direction at point P. At point P. The flux delta, the flux d psi. This is the flux d psi and delta psi, not d psi, delta psi passing through the surface ds delta s is the, this is the delta psi is the flux passing through the surface delta s is the product of the normal component of ds in the direction normal to the ds. Not ds, delta s. Next important point is the flux d psi or delta psi. The flux delta psi passing through the surface, delta s is the product of ds normal, the product of ds normal and delta s. ds normal, this is the ds normal. Apply cos theta is equal to ds by ds normal. Cos theta is equal to ds by ds normal, or this is the ds normal. Delta psi is equal to d psi is equal delta psi is equal to ds normal into delta s. ds normal is ds cos theta into delta s. This is the ds delta s cos theta, that is equal to ds dot delta s, that is delta psi. Therefore, psi is equal to integral of that entire closed surface. That entire closed surface is d psi ds dot ds. Entire closed surface. If this is the Gauss law, psi is equal to integral of our closed surface. That means entire surface ds dot ds is equal to charge enclosed. Charge enclosed in the surface, closed surface. Charge enclosed in the closed surface. Okay. For the charge enclosed is several point charges. The charge enclosed is several several point charges. That means Q is equal to sigma Qn. Second one is charge is due to line charge. Line charge, therefore Q is equal to sigma rho L dl. Surface charge. Next one is surface charge. Q is equal to surface rho s ds. Volume charge distribution. Volume charge distribution. Q is equal to over volume rho v dv. Out of these four is considered. Therefore, psi is equal to integral ds dot ds volume rho v dv. This is the statement of that Gauss law is the electric flux passing through any closed surface. This is the irregular closed surface. This entire one is the irregular closed surface. This is the distribution of charge. This is the distribution of charge shown as cloud of point charges that surrounded by the cloud of point charges surrounded by a closed surface of any shape. These are the cloud of point charges surrounded by a closed surface of any shape. This is the ds, not ds. Delta s is the incremental element of area delta s is very nearly a portion of the plane surface. This is the portion of the plane surface. This incremental surface element is a vector quantity. That means magnitude and direction. Irregular means these directions and magnitudes are changes point to point. The direction of delta s is delta s, which is normal to the plane of that surface, which is normal to the plane of the surface. ds is the electric flux density at a point P due to charge Q. This ds is making an angle theta with delta s. With delta s. Delta s is the direction of delta s, which is normal to the plane of surface. This is ds normal. Cos theta is equal to ds normal by ds. Therefore, ds normal is equal to cos theta into ds. Therefore, the flux passing through this delta s is equal to d psi is equal to, or delta psi is equal to product of ds normal into delta s. ds normal is equal to ds cos theta. ds cos theta into delta s. ds cos theta into delta s. Therefore, ds dot delta s. d psi is, or delta psi. Psi is equal to total flux passing through that closed irregular surface there is psi is equal to integral over surface is integral over surface ds dot delta s. That is the charge enclosed, charge within the enclosed surface. This is the statement and proof of that Gauss law. With this, the analysis is completed.